let's say this is a ring. Okay. This is our x-axis, this is our y-axis. Okay. Consider a small element of the ring which is making an angle d theta as shown. Now what is the length of this element? The length of this element will be r d theta. Agree? The length of this element is r d theta. R is the radius. R is the radius. What is the linear charge density here? Lambda naught sine theta. Okay. So this is the charge on this element. Okay. Since it is in the first quadrant, charge on this element is positive. Now what do you think? What is the value of sine of minus theta? Sine of minus theta is minus sine theta. Agree? Which means if I take an element in the fourth quadrant, and let's say this element also makes an angle d theta. The element also makes an angle d theta at the center. Then the charge on this element, point number 1, will be negative. Point number 2, the charge will be r d theta into lambda naught sine theta with a minus sign. Okay? This is the charge on the element. Agree? Which essentially means this is a positive charge, this is a negative charge. These two charges are equal in magnitude. Okay? These two charges are equal in magnitude. Remember, we have proved the charge on this element is this much. Okay? Lambda naught sine theta into r d theta. And charge on the lower element, the charge on the lower element is this much. Agree? Minus r d theta into lambda naught sine theta. Agree? So we can say that the charge on these two elements are equal in magnitude, opposite in direction, and therefore they make what? A dipole. Therefore they make a dipole. Okay? And what is the direction in which this dipole is pointing? This dipole is pointing in the y direction. Okay? The direction of dipole moment is from negative to the positive charge. Agree? If I take one element here, it will be positively charged. Same angle, another element here, negatively charged. Amount of charge will also be equal. So again, this will make a dipole in this direction. You take one element here, one element here. This one will be having positive charge, this one will be having negative charge. The magnitude of charge will be equal. Will make a dipole in this direction. Agree? So, this ring can be considered as if I have lot many dipoles placed like this. Agree or not? Agree or not? Each one of the dipole is pointing in which direction? Y direction. Okay? I need to find out the dipole moment of this ring. Means I need to add all these dipole moments vectorially. Now since all vectors are pointing in the same direction, their simple algebraic addition is nothing but the vector addition. Agree? You know that if two vectors are pointing in the same direction, then the algebraic addition is nothing but the vector addition. So let's now do the calculation. Okay? Consider an infinitesimally small element. The charge on it is a positive charge, lambda naught sine theta. The dipole moment of this system, this small dipole which is pointing in the upward direction, is magnitude of charge, which is lambda naught sine theta, multiplied by the distance between the two charges, positive and negative charge. Now how much is this length? It is r sine theta. How much is this length? Same, r sine theta. So what is the complete length? 2r sine theta. So what is the length of dipole? 2r sine theta, from negative to the positive charge. Agree? This is 2r sine theta. Agree? J cap. This is dp vector. If I add all of them, I will get p vector, which is nothing but lambda naught 2r j cap integral so it will become sine square theta sine square theta d theta. Now we need to see what is the lower limit and the upper limit. Okay, if I take theta equal to pi by 4, I get these two elements. Agree? If you take theta equal to pi by 2, you get these two elements. If we take theta equal to 3, let's say theta equal to 120 degree, we get these two elements. Agree? So what should be the value of theta? What should be the limits on the theta, so that if the variable vary from lower limit to the upper limit, whole of the body should have been covered. Whole of the ring should have been covered. It will be 0 to pi or 0 to 2 pi. You see, if you take pi by 4, you got these two elements. Okay. So it's clear that the limits must be between 0 and pi. Okay. Now the rest is quite simple. Lambda naught 2r square j cap integral of sine square theta d theta between 0 and pi. The value of the integral comes out to be this much, and therefore the dipole moment is this, pointing in the y direction. Okay. Now a homework. Find out the dipole moment of a ring for which the linear charge density is lambda naught cos theta. For which the linear charge density is lambda naught cos theta, where theta is this polar angle. Theta is this polar angle. Okay. Now we'll talk in the next.